I'm going to draw a graph of the function log base 4 of x, and then from that graph I'm going to use transformations to graph log base 4 of x minus 3. So to graph f of x equal to log base 4 of x without a calculator, the first thing I'm going to do is I'm going to rewrite this in exponential notation. So the base is 4, the base of my exponent is going to be, my exponential function is going to be 4. The power that I'm raising it to is going to be y, and then that has to be equal to x. So I'm going to make a chart now using this function. This is my log function rewritten as exponential. I have x values and y values, and I'm going to pick y values to find out what x is going to be equal to. So the y values I'm going to pick are -2, -1, 0, 1, and 2. Plugging that in, if y is equal to -2, I would have 4 to the -2 is equal to x. And whenever I have a negative exponent, I can rewrite that with a positive exponent by writing it as 1 over, in this case 4 to the 2nd, which becomes 1/16. So when y is equal to -2, x is going to be 1/16. I'm going to do the same thing for when y is equal to -1. So I have 4 to the -1st is equal to x. So 1 over 4 to the 1st is equal to x. So it's 1/4. Then I have 0. If I put 0 in, anything to the 0 power is always 1. And then we have 4 and 16. So I'm going to go ahead and graph this now. So graphing 1/16 -2. So 1/16 is going to be very close to the y-axis, and we're going to be down at -2. Then we have 1/4, -1. Then we have 1, 0, 4, 1, and 16, 2. So drawing my curve. So this is the graph of y equal to log base 4 of x. Next I'm going to draw the graph of log base 4 of x minus 3. And to do this, this means I'm going to be moving in the x direction, the horizontal direction, and I'm going to be moving to the right 3 units. Everything else is going to stay the same. So looking at all of my coordinates I have for x, they're all going to be adding with 3. So I'm going to write my new coordinates here. So I'm going to have 3 and 1/16, and I'll have 3 and a 4th, and then I'll have 4, 7, and 19. So I'm adding 3 to each one of my x terms over here. My y terms aren't going to change. They'll still be -2, -1, 0, 1, 2. So now drawing this on the same graph that I've just drawn, my y equal to log base 4 of x, I have 3 and a 16th and -2. Then I have 3 and a 4th, -1. And then I'm going to have 4, 0, 7, 1. And then I'm not going to be able to graph the rest because it's going off the paper here. But you get the idea. So now looking at our domains and our ranges, for my first function, my domain was from 0 to infinity, not including 0. And my range was all real numbers. And then I had a vertical asymptote at x equal to 0. My second function, my domain has changed because now I'm approaching 3 instead of approaching 0. So my domain for my second function is going to be 3 to infinity. The range is going to be the same, -infinity to infinity. And then my vertical asymptote also changes. So instead of having one at x equal to 0, I'm going to have one that you don't see at x equal to 3. Now I'm going to do 2 graphs where one is the log base 3 of x and the other one is f of x is equal to log base 3 of x minus 4. So to graph the first one, I'm going to first rewrite it in exponential notation. So the base on my exponent is going to be the same as the base on my log, which is 3. it's going to be raised to the y power, and that's going to be equal to x. I'm going to go ahead and plot points for x and y of my exponential function, and I'm going to pick values for y, -2, -1, 0, 1, and 2. And just like with the previous example, when I put in -2 for y, I can rewrite that with a positive exponent as being 1 over 3 to the second, which is 1/9. So when y is -2, x is going to be 1/9. When y is -1, x will be 1/3. When y is 0, x is 1, 3, and 9. I'm going to go ahead and graph this now. So graphing the different points, I have 1/9, -2, 1/3, -1, 1, 0, 3, 1, and 9, 2. So this is the graph of my basic function. Now I'm going to take the same graph, and what am I going to do with it? Well, this -4 is outside of the function. When I say it's outside of the function, it's not part of the logarithm. The only thing that's part of the logarithm is the x. So the -4 is outside the function, therefore it means I'm doing something to my y values, and what am I doing? I'm going to be moving down. So I'm going to be going down 4 units. So looking at all my y values that I have here, I'm going to subtract 4 from them. My x values are going to stay the same, so I have 1/9, and I'll have -6. 1/3, -5. 1, -4, 3, -3, and 9, -2. So now graphing this, so I have 1/9, -6. So this is 5, 6 down here. 1/3, -5. 1, -4. 3, -3. 9, -2. So looking at the domain of my first function, it went from 0 to infinity. My range was from -infinity to infinity. And my vertical asymptote was x equals 0. And my y-intercept was at 1, 0. My second graph, my domain is still going to be from 0 to infinity. It's still approaching the y-axis, just approaching it a little bit lower. My domain is going to be the same. It's just going to be shifted down 3. Eventually, though, my graph will cross the x-axis and we will continue on up into infinity. So my range is still -infinity to infinity. My vertical asymptote is still the same, x equals 0. And by looking at my graph right now, I don't know what my my x-intercept is going to be. This is your x-intercept. I don't know what it's going to be. I could figure it out, but right now we're not worried about that. We're just looking at our graphs.